So on number 6 on the review, the negatives under a cube root are fine, right? So what you're going to be doing is going through your list of perfect cubes. 1, 8, 27, 64. What was the next one? I gave it to you yesterday. Thanks. Okay, and you want to see, is there a number in 81 besides the negative that you can divide by? And there is. It's 27 and 3. Okay, so I'm using this number. I'm also, since 27 is what's coming out, I'm going to take the negative with it. Okay, so remember how we do this. The cube root of negative 27, and here it is on your calculator. Know this for the test tomorrow. Math 4. That's how you do a cube root. Okay, and I'm doing negative 27. Gives me negative 3. That's coming out. So I'm crossing that out. I'm going to put it up here for just a sec. And then the 3 is left over inside. Okay, so when I simplify this whole radical, the negative 3 is going to come down in the front. So anything I put up top goes to the front, and I multiply it by the 2. So that's negative 6 cube roots of 3. So that's the first radical simplified. Then I have a minus, but I'm going to hold off on writing anything. Negative 3 is not in our cube root list, all right? There's no number that goes into 3 and we don't count 1, but we have to take the negative out. So we want to make that a positive. So it's like saying negative 1 times 3. The 3 stays inside. The negative 1, what's the cube root of negative 1? 4. Negative 1 gives me negative 1. That's what's coming out. I multiply the negative 1 times what's out in front. What's out in front is a negative 1. So negative 1 times negative 1 is just positive 1. You can put the 1 there if you want, but you could leave it out as well. So this radical is now simplified. That 3 is inside. We never leave a negative inside the radical. Okay? And this one's exactly the same, right? This is negative 1 times 3. The negative 1 comes out, stays a negative 1. The cube root of negative 1 is negative 1. 3 is stuck inside. And then I have negative 1 times 2 is negative 2. Cube roots of, what did I circle? 3. So there's a lot of work in that problem just to get ready to add and subtract. Okay? But once I do all of that, I look at the numbers out in front and I add those together. So I have negative 6 plus 1 is negative 5. Negative 5 minus 2 is negative 7 cube roots of 3. So that would be your final answer. Now, there's a lot of steps in there, as I just said. The more work you show, the more credit I can give you. Remember, I said that yesterday. I've been saying it to you all year, okay? But I fight for you, okay? I'm not just like, wrong. Oh, that was right, wrong, F. I look at what you write. So if you just skip a bunch of steps and then you get it wrong, I can't give you credit. I can't go in your brain and see what you were thinking. So just remember, the more work you show, the easier it is for me to give you some partial credit. I search. Even with some people's handwriting, I search. Okay? Is that good, Mandy? Sarah / Mandy. Mandy asked for that because she's not here. She asked Sarah to go over that. More. Ask me more. Yeah. 15? I'm happy to. Anything you guys want. Okay, so on the back is where our equations are. I might just do, you know what I'm going to do? I'm going to do 15 through 23 in the middle of this. Okay. I'm going to just go for it and do 15 through 23 because why not? And then I'll go back and answer anything I haven't gone over. So if you haven't gotten to the back or if you struggled with anything on the back, now is your chance to get your questions answered, okay? If you don't need my help, just keep working. Tune me out, but don't ask me later to go over something or to come over. Okay, here's the thing. If we have a radical in our problem, we have to get it by itself before we do anything. Meaning, if it's already by itself on one side, we're ready to start the process of getting rid of the radical, which is what we need to do. But if there's somebody on the same side, you have to move it to the other side. This is negative 10 plus this. So to get this to the other side, we would add 10. We want to make a 0 here. Now that goes away. What we do to one side, we have to do to the other. And that gives me a 6 on the left-hand side equals the square root of x over 4. Okay? Now, I need to get x by itself. That's what your goal is with an equation. Isolate x. He needs to be by himself. Everybody and everything else goes away. So to get x out of this little prison of a radical, we do the opposite operation, just like we did up here. The opposite of square rooting something is squaring it. So when I do 6 squared, I get 36. And when I square a square root, it gets rid of the radical, and we're just left with x divided by 4. Most of you, when you read that, you would say x over 4, and that's not wrong. It's fine to say x over 4. But remember, this is division. So to continue with our opposite operations, x divided by 4, opposite of division is multiplication. What you do to one side, you have to do to the other. So over here, the 4's cancel. You're left with x. That was our goal. And then right in my calculator, 36 times 4 is 144. Ash, does that make sense? Are you okay with that? Okay. Let's do another one of those. 16. Give me a second to write it. Now, look what's different in this problem. So we want to get b by itself. It's under a radical. Remember the rule. I have to get the radical by itself. I can't square this with the 4 there. I couldn't square this with the minus 10 there. So I have to get rid of the 4. Look at the difference. This is a mistake I see all the time. What does this, let me ask you, what does the 4 right up against the radical mean? What operation does that represent? What, Brian? Multiplication, right? 4 up against an x, right? Let me find this. 4 right up against an x, that's multiplication. 4 right up against parentheses, that's multiplication. 4 right up next to a radical, all of those mean multiplication, okay? This was not multiplication. It was not right up against it. It was separated by a plus. Notice the difference.
So 60 means multiplication.
Say it again.
So extra plus 60 means multiplication.
Right here, this is multiplication.
Yeah.
So what's the opposite of it? What's the opposite of multiplication?
Dividing.
Yeah. So to isolate the radical, I'm going to divide both sides by 4. Okay? So 4 divided by 4 is 1, and these 4's cancel. 4 over 4 is just 1, so we're left with 3b minus 14. So we got the radical by itself first. Okay? Now, to get rid of it, same steps as over there. We're going to square this side and square this side. 1 squared is 1. And when you square a square root, you're left with just what's under the radical, right? And now it's a 2-step equation. Add 14, divide by 3. Add 14, divide by 3. Show the steps, guys, so I can give you credit where you were correct. Okay? A lot of us, and I've done it, I am really good at math. I don't mean to brag, but I am. And there are times that when I do this in my head, I'll subtract 14 from both sides. I've made that mistake a million times. I see my students make that mistake. So showing the work on such a high stakes point thing, like a test for this class, it doesn't hurt to just show the steps. And that way I can see if you made a mistake, what the mistake was, and still give you some credit. Okay? Good on 16, everybody? Yeah? Yeah, Mariana? Sure, why not? 17. The square root of, yeah, she's going to the bathroom, Erin. She can get it. Thank you. So number 17, I got to get the radical by itself. What do I do to get the radical by itself? Trick question. Brian, what do I do to get the radical by itself? What? No. Wait. It was a trick question, kind of. It's already by itself, is what I was looking for. Sorry, because you answered it on the last question. I thought you would just go with me on that. All right, that was kind of mean. The radical's already by itself. There's no steps I have to do ahead of time. I can go right into square this side, square this side. Okay? Dylan, you should be staying with me on this stuff. You just missed a whole bunch, and now you're on your phone. This test is tomorrow. Not an easy test. Okay, square both sides, subtract 6, n is 30. Okay? Any questions on 15, 16, 17? Isolate the radical, square both sides, solve for the variable. Okay? There's 2 of these on your test, 2 of these types of problems. Okay? So I'll jump back to the worksheet to do these. Yeah. Do what? Well, I'm going to do these first, but I will go back and do anything you need. Okay? All right, so 17 and 19 are taking a radical and writing it in exponential form. So my answer should have an exponent in it. So we start with whatever's inside, that's n, and we write it to a power, exponent. That exponent is whatever's on the outside of the parentheses, or whatever is the power, given to the radical. In this case, it's 3. And then what's inside that little hook? What number? 2. Not 1, 2. 3/2. That's it. There's no work to show. N to the 3/2. That's it. N to the 3/2. Okay. This one. So there's only, think about this. There's no power on the outside. Let me show you something. This one right here could have been written. Let me write it the way that we showed it. Another way that could have been written would be this. It means the same thing, okay? So here, the 6 and the x each have an exponent of what? What are their individual exponents in this problem? 1. So we have 6 to the 1/3 times x to the 1/3. Or you could put them together in parentheses to the 1/3. Either way would be perfectly fine. And you can just leave it. You leave it just like that. That's the answer. It's just writing it in its other form. And now we're going in reverse, going from exponential form to radical form. Just do what you just did in reverse. So I'm going to draw myself a radical, because I know there's going to be a radical in my answer. It's a square root, so I'm not going to put a number here. I wouldn't mark it wrong if you did. Okay? If you put a 2 in here, I won't mark it wrong. And then we have 6x inside. So I'll write it the 2 ways you could write this answer. You could write 6x, the whole thing, to the power of 3, which is really the preferred way. Or 6 to the 3rd, x to the 3rd. That's giving both of those a 3. So remember, parentheses means include everything inside, gets the 3. Or it's almost like the distributive property. You're giving the 3 to the 6 and the x. What you cannot write, what you can't write is like this. I don't even know what that looks like. You have to somehow show that the 3 is to everything, so you would need the parentheses. Okay? I don't know what's going on in Mr. Fidel's class. Okay, again, making a radical. That's a square root again. You can put the 2 there if you want, or you don't have to. N inside. You could put n to the 1st if you wanted to, but you don't need to. That's as simple as it gets. No work, no calculator needed. It's just knowing how to write things in their other form. Okay? So I'm hoping 18 through 21 will be kind of like freebies for you. Okay? So when I'm done and I walk around, let me know if you were unclear about those. We'll go back in your notes and see other examples. Okay? All right, let's do these last two equations. There's one or two on your test. I can't remember. Again, I'm going to write on regular paper because I write too big. And then I'll go back and answer 7 for Sam and anything else. I think it was 7, right, Sam? Yeah. Okay, guys, remember the rule with radicals? You have to have the radical by itself before you do anything. Same exact rule with exponential functions. The parentheses with their power have to be by themselves on one side of the equation. Didn't that already occur? We're already by itself. If you look ahead to number 23, we're going to have to get rid of the -4 before we do this next step, okay? So you have to isolate the parentheses first. And then, it feels like forever ago that we did this, even though this is the most recent thing. I don't know. You multiply, remember, because you can do anything you want to an equation. Anything. Anything you want. Anything. If you want to add 7 to this side, you can, but you have to add 7 to that side. But what would that do for us? Nothing. Okay? So I'm going to use the reciprocal, the flip of 1/2 on this side, because guess what? 1/2 times 2/1 is what? What are these two fractions multiplied together equal? 1. So on this side, when I multiply by the reciprocal, I'm left with just 48p plus 1. That's my right-hand side. How easy is that? And then I just have to do the same thing to the other side. Another way of writing 2/1, of course, is 2. Right? 2/1 is 2. So that gives me 49. 7 times 7. And now it's a 2-step equation. Nobody can think that's hard. Come on, come on. If you know how to start the problem, it's kind of like, oh, look at that. Look how easy that is, you know. Showing all these steps for partial credit if it's needed. Okay, so like I said, number 23 has a number in front of the parentheses. I can't do that multiply by the reciprocal business until that -4 goes to the other side. So I have to do that first. Remember, number right up against parentheses represents multiplication. So the opposite is division. And you guys know I love to check test and quiz reviews as homework checks. So with me doing pretty much every problem with you between yesterday and today, maybe on every problem, you should all have full credit when I check this. Okay, so now that I have the parentheses and its power by itself, now I'm going to multiply by this number flipped. Same thing to the other side. I'm just writing it a little neater on that side. Instead of 2/1, I just wrote 2. They mean the same thing. So 1/2 times 2/1 is 1. 2 squared is 4. And then just solve for x plus 2 Do we feel better about the 15 through like the equations part? Ashley, are you feeling better? Yeah. Okay. So number 7 was requested. So if you want to look at number 7 and see if you need help with it, I'm just copying it on my paper so I have room to write. Yeah. Yeah. Okay. So as we've been talking about over and over and over and over again today, if you have something, anything right up against the parentheses, that means multiplication, right? So this is just the distributive property. We're going to multiply square root of 6 times the square root of 6, and the square root of 6 times 3 square roots of 10, okay? With multiplication, the only rule is that you multiply the stuff on the outside. If there's numbers out in front, those get multiplied. And if there's numbers underneath, they get multiplied. So if no numbers out in front, we're just going to go right to the square root of 6 times the square root of 6 is the square root of 36. Is that good right there, Sammy? Yeah. Okay, and we'll simplify that in a minute. You might notice that can be simplified. Then I'm going to do the square root of 6 times 3 square roots of 10. So the 3 is just hanging out front. He's like multiplying with a 1. 1 times 3 is 3. And then 6 times 10 is 60. There's definitely one like this on the test, I remember. It's very similar to this. Now, so getting to that point would get you some points, okay? But you always want to try and simplify it. Just like you would never leave 4/8 as a final answer, hopefully you would remember that you have to simplify fractions. You have to simplify radicals. The square root of 36, that's a perfect square. It is 6. So that one's done. And 60, look at my list of perfect squares and see if there's any number that goes into it that's on that list. Like when I do 4, 4 goes into it 15 times. There it is. 4 times 15 is 60. So remember how we do this. 4 times 15. 4 comes out, put it up here, becomes a 2, and 15 is stuck inside. Now to simplify it, the 2 comes down times the 3. Remember, if there's already something out in front, they just multiply. So that becomes 6. Square roots of what? What's inside? 15. That's this number. And then 6. And that would be your final answer. Does that make sense? More. What else can I do for you people?
Then you go to the 43.
Yes, what were you going to ask, Devin? Yeah. So I'm going to do number 8 first since it's just like this, and then I'll go back and do 13 and 14, I think you said. Okay, so 8 is another one that has a radical right up against the parentheses, which represents multiplication. Okay, does that make sense, Devin? Multiplication. So then I'm going to do square root of 5 times this term and the square root of 5 times this term. Okay? So think about it. If you needed to put a 1 there, that's what's out in front. So it's 1 times 2 is 2. 5 times 2 is 10. Good? So we're done with that one. Then 1 times 4 would be 4 on the outside. 5 times 10 is 50. Now, can we simplify? Like, do I have anything I can simplify? If you go through the list of perfect squares, there's nothing that goes into 10 that's a perfect square, okay? But 50 has... Okay. The square root of 25 is 5. I'm going to put it up here for a sec. Deal with it in a minute. 2 is left over inside. So I have 2 square roots of 10, right there. Then now I'm going to bring the 5 out in front. If there's already a number there, we multiply them. And then the 2 is left inside. And that would be your final answer. We can't combine unless these are the same exact number. Okay, good. Okay, I'm going to do some graphing. Nope. What did you say? What numbers?
13 and 14.
Yeah, graphing, 13 and 14. These are cube roots. Our cube root list is different from the square root list, if you remember. So for a cube root, we always start with 0, 0, 1, 1, 8, 2. We also do the negatives of these numbers. So it's 0, 0, 1, 1. Notice I'm using x's. 8, 2. But remember, you can have negatives under the radical. So we also use negative 1, negative 1, negative 8, negative 2. So it makes like a S-looking shape. That is this part right here. That's that. Okay? We just did that. That's this right here. What does that plus 1 tell us to do to all of those points, JT? What direction does the plus 1 take us? That's what you have to study, guys. So here it is again. whether it's a cube root or a square root, okay, since we're talking about cube root, I'll stick with that. Don't forget, the number under the radical is left and right, but it's always opposite. Remember, minus is to the right, negative is positive is to the left. And this number that's not under the radical, like the one we have here, JT, is your up and down. So this is actually up, because it's not under the radical. See how it's all the way outside of the radical? That's your up and down. Underneath, we'll do one in a second, is your left and right, okay? That's the difference, and it's important that you know that. So at that, once we decide that, we just literally go up one. We just go up one, up one, up one, up one, and connect those points. Guys, the work I just showed here is the work I would expect to see on your test. I want to see your table. I want to see your X's. I want to see your final graph connected. That's how we've done it every single time. That's how you should do it on the test. And this is the same thing. It's the same table of values, right? This. Right? We start with the same points for cube root graphs over and over. And then, so JT, what's this minus 2 underneath going to do?
Down.
No, it's underneath. See how it's inside? It's inside the radical. That's left and right, but it's always opposite. So normally we think negative to the left, but underneath it's always, it's right. So guys, it's okay to go off your graph. Look, that's it. Look, the right two. It's okay. No big deal. And then connect them. Oh, that was horrible. Hopefully yours looks better than mine. Okay, JT? What else? Ashley, you have anything else? Devin? Evan? You look like you're contemplating. You look deep in thought. Anybody in here signing? I know Evan is, right? Anybody in here signing up for AP Pre-Calc next year? Yeah. Evan, are you definitely? Anybody else? AP Pre-Calc? Oh boy. Tyson. Tyson's going to get an A in my class. Without showing work, without participating, without being on time, he's going to get an A. What? Anything else, my dears? Just know if you are taking that class, I'm a different teacher in that class. I teach bell to bell, much faster pace. You have to put your phones up the entire period every day, not just test days, okay? But you'll definitely have me, because I'm the only one that teaches it. So if you like that, that's fine. If you don't, there's no chance of getting somebody else. All right, I guess I'm going to stop recording since nobody has any questions. Devin, do you have anything else you want me to go over? Okay. Okay.